Hello. All right, making sure everything is set up. Welcome, everybody. It is great to be back. This is my first stream of the new year. And so it's been a while. It was a nice, I think I might have taken 3 weeks off. But I'm happy to be back to learning TensorFlow. If you're joining for the first time, I am Becca. I'm a front-end developer. I'm really interested in exploring technology that can solve problems in the world around me, and that's how I came to TensorFlow.js. It's been one of those things that has inspired me for a really long time. If you want to catch some of the back episodes, you can go over to my YouTube channel. I am using the amazing Gant Laborde's book. Let's see if I can do this without showing glare. Yes, Learning TensorFlow.js. It's got the turtle on it. It is well read, as you can see. So I am very happy to be back here and sharing again. We are doing a giveaway for Gant's book, so stick around, say hi in the chat if you want to be entered into the drawing for his book. I believe that is signed by him and some other cool things. So we are at chapter 7, and I think there are 11 chapters that we're doing, so just 4 more, 7, 8, 9, 10, 11, yes, 4 more chapters that we'll be working through in the next couple of weeks. So I guess the next month, and then we're going to see what happens there. I've got some ideas for where I want to go. If there are other things that you'd like to see, I might stick with TensorFlow.js. I might shift it a little bit, but I'm hoping to keep on streaming because it's been really fun learning how to stream while learning TensorFlow.js. So welcome. Oh, I'm going to throw some links in the chat right now. So if you want to know more about the amazing Gant Laborde who wrote this book, there are some links for you. If you want to know a little bit more about me, you can follow me on Twitter, or you can come catch up at Virtual Coffee. It's the community that I help maintain. We meet up every Tuesday and Thursday. So Tuesdays have been a lot of fun for me because I am doing virtual coffee in the morning, getting to chat with lots of cool folks. And then in the afternoons, I am over here streaming on Twitch. And usually sometimes in the middle, some fun things happen. I went to the first TensorFlow.js working group meeting just before this. It's cool to see some of the new stuff that they're working on and talk to or listen to mostly. I just mostly listen to what people are working on or what they're interested in doing. So a little bit about the stream today. We have been talking a lot about TensorFlow.js and what we can do with it. We've looked over some examples. We've done object identification. We've looked at TF Hub, where you can find different models. Today, we're going to be looking a little bit more at model making, and we're going to be talking about data sets, which I've learned a lot about in the last year. And honestly, I think data sets are one of the first things that got me interested in working with machine learning, because I just think that it's fascinating to think about what we can do with that data and the problems that we can solve. And so maybe we'll solve some problems today on the stream. Let's see. So we've talked about the models from TensorFlow Hub, which is, I think it's tfhub.com. But those aren't the only. Hey, Nick. Welcome. Welcome. I see a couple people filtering in. If you want to be entered in to win Gant Laborde's book and some other cool stuff from him, go ahead and say hi in the chat. Hi, Ayo. It's great to have everybody here. So we talked about TensorFlow Hub, and that's where you can find some different models. But I want to say, that's not what we're limited to. We're not limited to what is Google approved, and we can spread our wings a little bit and see what else is out there. And so we're going to do some of that exploration today. Hey, Michael. Yes, I'm not sure that's the type of model we'll be talking about today, but I think that you should definitely go for it. We're going to be looking at new ways to make models from existing models and gathering and understanding data a little bit. So one of the things that I think that is important to note is TensorFlow.js has not been around that long. And so we don't see a huge number of models if we're comparing it to other frameworks. So we can do a couple of different things to kind of navigate through that problem. We can look outside the Google endorsed models, and we can think about converting other models or models written in other frameworks into TensorFlow.js. And I know that's one of the things that we've been talking about in the study group a little bit. You know, what are we supposed to do with TensorFlow.js? We have to make these conversions a lot. And it does happen. And there are ways to do it that simplify it a little. I'm not ever going to say that anything is easy, because I feel like I can definitely find a way to make it hard no matter what. So there's always the potential for making things harder than they should be. So one of the things that you might hear tossed around is this idea of model zoos. So it's just kind of a colloquial term or familiar term that you would expect. This is a place where there are a bunch of different models. And so when you're browsing a zoo, you might not find the right model exactly for what you want, but you can have inspiration for the model that you want to build, or to convert a model of a different framework to what you need to be doing with it. And so there's always potential. And so I just love the exploration part of things, to be able to dig in and think about what other people are doing, and how, you know, we can work together to do something really cool. So you will find that a lot of Python programmed TensorFlow models are out there, and they're saved in a format called Keras HDF5. I think I got that right. Hierarchical Data Format version 5. But that's not what people normally say. They might just refer to it as a Keras model or V5, because that's much easier to remember. So Keras file formats have an architecture that specifies the layers of the model. And so one of the things that I've learned over the last 6 episodes is that there are different layers in the model. So you can add different things. So you might have a different need, or you might need to look for something more specific, and that might require adding a different layer to that model. So, you know, you might have like a Neapolitan cake with vanilla and chocolate and strawberry. I think those are the 3 things that are in Neapolitan cakes. But you're looking for different things in each of the layers of those cakes, essentially. You know, they shouldn't all taste the same. I don't think they should. I imagine that the pink layer tastes like strawberry, but I could be wrong about that. Maybe that's why it's always so disappointing. There's also some other files in there that are useful. The Keras models are the ones that are a little bit easier to convert to TensorFlow.js. Hey, Practical Dev, and yes to all of the cake. I love cake. So to do this conversion, there's a way to do it. You have to install Python on your computer. I have not played with Python yet. It's something that I'm interested in doing, but you convert it with pip, P-I-P, which I have learned is a package installer for Python, similar to NPM if we're thinking in the JavaScript world. So there are these tools that make it simpler for you to do it, but again, I just want to say there's always a way to make it difficult. All right, let's talk a little bit about customizing models. So you might find a model that suits your need, and you might use it as it is right out of the box. But that's not likely going to happen. All right, PyEnv is great if you're working with different versions of Python. That is good to know. I need to write that down. I'm just going to type it in my notes now, because otherwise I'm going to forget, and maybe I'll write a blog post about this and get that information out there. So thanks for the tip. All tips are appreciated, not monetary tips, but tips like that in the chat if you have any. All right, so you're probably not going to find a model to suit all of your needs, and you might have to train that model, or you might need to modify it in some way. So sometimes it makes sense to use that existing model rather than to create your own model, because that takes a lot of time and understanding and know-how. And rather than retraining that whole model, we're going to add those layers. So we're going to add that chocolate layer or that vanilla layer to our cake. This is just a really, really terrible analogy. So someone give me a better one. But the idea is we might want to look for something more specific. So maybe we have a model that identifies dogs, and instead of just identifying dogs, we only want to identify pug dogs. And so then we're going to get more specific with what we're doing there. So we're going to look for all of the pug dogs. Now, I am going to do the only normal thing that I think makes sense, and I'm going to talk about rashes because this is what I talked about at Virtual Coffee last week. So I don't know. So this is like a tangent, but it's going to be a theme throughout this stream today. So if you're a parent or maybe a person who has a number of rashes, you will find that you're always looking up, what is this rash? And, do I need to take my kid to the doctor? Is it something that's going to go away on its own? And there are a number of people out there who put pictures of their rashes that are most definitely not the type of rashes that I am looking to identify, and it pops up on my image search. So I would really love to not see those rashes. So rather than, having a model that looks at all of those rashes, we're going to look specifically for poison ivy, or one of my least favorite, Lyme's disease, which is caused by deer ticks in this area of the United States, which is really an awful thing. My 7-year-old had Lyme's disease, but that doesn't really have to do too much with it. You can look up Lyme's disease on your own. And look, people are leaving now because I am talking about rashes. So the idea here is that this allows us to do, so if we're retraining this model, or if we're adding a layer to this model, it allows us to work with the model with much less data. And this is called transfer learning, which is a really cool way to build on something that's already been created. And actually, there's a lot of really great usage of transfer learning. So maybe I think we're going to talk about that more, in a couple of streams. So I'll have some better examples, maybe not about rashes, maybe about rashes. But today we're going to look at Teachable Machine with Google.com. So I'm going to drop that link in the chat. And I like this because it's pretty user-friendly. Last year with my oldest, we worked with it on his science fair project. We failed miserably with it. I'm not really sure what went wrong. And it's a long story, but I thought I have ruined science fair for him. And I loved science fair as a kid. I went to state science fair twice. I'm not bragging. I got a superior once. But anyway, yesterday we were working on his new science fair project. And he said, I really liked that one that we did last year. I'm like, okay. It took him a year to recognize that he liked it, but it was a really, a pretty good one. So we're going to go ahead and take a look at Teachable Machine. Where is it? Oh, it is here. No, that's not what I want. Here we go. This is what we're going to be looking at in a second and working with. So what was I talking about? Now it's time to focus my brain. So here are some of the things that we can be doing. So we've mostly been, this is exactly the project that we did. We did the marshmallow cereal sorter, and we failed, but it's okay because you can fail in science fair, and as long as you say it didn't do what I thought it did, and this is why I think it went wrong, you are okay. I'm going to click get started so we don't have to see that over and over. We've been working with images so far, I think, in this stream. I don't think we've done anything but image detection and that kind of thing. So we're going to go ahead and work with one of those projects, and we're going to look at the standard image model. So this tells you a little bit about it, but we can run it completely in the browser. We can create our data set in the browser. They make it really easy to play around with it, and this is one of the reasons why I like it so much. But in the book, Gant talks about some different examples, like maybe you want to do identify thumbs up or thumbs down. I'll try to do this like awkward angle for my camera. Well, with post-it notes or not post-it notes. If you have other ideas, go ahead and drop those in the chat too. But you, let's see, what else? He said, am I drinking water? Which cat is this? A secret handshake if you want to unlock something. He also does book or banana. But the idea here is like it can be something that you build off of. So maybe you, there's, you know, if you drink coffee, then a little message pops up like drink your water. And then you're like, oh, okay, yes. It is time to hydrate. So I think it's fun to think about like, okay, what are the projects we can start with and how can we build from there? And with Teachable Machine, it gives you all of the code that you need to kind of take this project with you. You can download your data set, and oh, that's actually maybe the site that I initially clicked instead of this one, was taking me to more directions of what I can do with this. So let's see. This was my favorite. So Gant has the example like, is daddy working or is mommy working? And if you hook it up to your Alexa or your Google Home or something like that and say, if it identifies that you're working, and your kid asks your Alexa or whatever, is mommy working? And Alexa knows to say yes if you look a certain way. And I really love that example because, well, a number of times I've had kids come into meetings, and a couple of people have suggested you should mute your computer when you give the mom look. So the mom look is like a turn towards my door is that way, and like a stern face. If anybody watched Home Improvement, Jill from Home Improvement gave the look, right? And so the way to build off of that, the way to add to this would be, okay, let's identify whether or not I've got my working face on, and if I do, then we can classify that, and then we can do something with that. Like Alexa says, your TV time is going to get taken away. It makes an announcement or something. I don't know. But those are some ideas. So if anybody has ideas for what we want to do here, we can add different classes of things and see how it works out. We can do mom look, we can do hydration, or we can do something else. But we're going to go in and we're going to work on creating an example. And I think, can you all see this okay? I'm not sure that I could really make it any bigger, but I would hate for this to be something that you can't really see. Well, we're going to do our best here. Yeah. Oh, well, now, there we go. I made it bigger, but now I've got to scroll a little bit. That's okay. All right. Thanks, Nick. So, class 1. What should we do? We can do hydration. Practical Dev says hydration is important. So we'll go with water cup. Maybe that's not the best class name, but that's what we're going to go with. And then class 2 could be coffee mug. And so these are our 2 different labels here, and we're going to create these data sets. Now, what do you think are some things that can impact your data set or our data set right now? Now, we're going to talk more about this in a little bit, but for this specific example, if I am using this tomorrow, I might not have the same lighting, right? So lighting definitely can affect the way that it sees the images. Another thing is too, I have a headband on today. I almost never wear headbands. I don't know. I just went for a headband today. It's headband man. So that could impact what it's looking at based on, how we create this data. So also my position. So if I'm not in the same position, then it might have a different indication. So these are all of the things that we can think of. But we're going to go ahead and start by taking so when you're creating a data set like this, what you want to do is like move to different positions. You can look around. I don't know. I don't think I could really drink from a water cup looking like that. It would be difficult to, because of where I'm at in my camera view, to identify where the water is. So for the sake of the stream, I'm just going to make sure that I have it pretty high up. We can change the lighting too in the background. I don't know that this will particularly impact it, but for sure it could, especially if you're doing something like rather than identifying water, if you're looking at a pose of somebody, or if you're doing more like image segmentation where you're looking at the whole body to indicate something. So let's see here. The nice thing here is they've got it all taken care of to tap into my webcam. So there's very little work that I need to do to get this right. And so one of the things that you can see too is you can crop this if you need to. I think we did a lot of cropping with my son's project, and I wonder if that impacted it. But you'll see you can also crop the preview. I'm not sure how that impacts it, but we're not going to crop right now. I'm going to hold it down to record some images. I'm going to move around, and then we'll go from there. Now I'm nice and hydrated. We could also do it again without the headband. We only have 56 images here, so we can do some other things, maybe low lighting. I found that this is one of the things that the last time maybe that I was working with a model, I didn't realize how much the light impacted the accuracy of of the results. And so changing the lighting made it much less accurate or more inaccurate pretty easily. So let's do some low lighting ones. All right. I don't really want to take my headband off because then it's going to mess with my hair. But I'm going to turn the light back on. And get back into focus maybe. All right, there's 102 of those samples. We're just going to go with that for right now. And that now we're going to look at the coffee mug. So this is me drinking my coffee, although it is empty. I have already had 3 glasses of, espresso today. That's about the same amount I think we did last time, 56, with the water cup. And this is interesting too because the coffee mug on the bottom looks a lot different. So that for sure could impact it, right? That wouldn't, if you see it from this angle, you almost don't see any mug at all. So I think that it's definitely good to have that shot in there. I wonder if there's, I wouldn't really drink it like that. But all of the things that you need to think of. I don't know if I have any of me. Yeah, I'm not really sure what's happening here. Well, that's a side of me, so you can still see it. But you can also, the nice thing is you can go through and delete these as well. Again, they make it pretty easy to work with. I'm going to turn off the light again and make sure I get some of these. Get some forward. All right, we're at 116. That's close. If we want to, we can go back. I usually like to make it even, but for now, we're going to pause and we're going to let it train this model. So what's happening here is the Teachable Machine is using our images for transfer learning and retraining the MobileNet model, which I'm pretty sure we used the MobileNet model in a previous, oh, bye IU, you can catch the replay tomorrow. Thanks so much for coming. I think we used the MobileNet model in one of the previous live streams, or at least talked about it. But so 85%, about 85% of our data is going to be used to train the model, and the other 15 is going to be used for testing the model's performance. And you'll see that this works pretty quickly. So there's okay, we're going to go into a little bit more, but let's first see what comes out here. Okay, so, well, this is not good, right? Because it thinks that maybe I have a water cup or a coffee mug. So what kind of data do you think I'm missing here? Probably me without a coffee mug or a water cup, right? Let's go ahead and see if it can identify whether or not I've got a coffee mug. Oh, look, that's good. Okay, when I shift, it's a little bit harder. It's even good. Wow, that's pretty. It knows. It's like, that is definitely a coffee mug. Let's turn out the lights and see what happens. Oh, definitely a coffee mug. It's good. We did an excellent job. Good work, team. High fives. All right, so now let's see if it can identify the water cup. A little bit having a hard time in that corner. So I wonder if there's not too many here that have the water bottle in the corner. So what we can do is add some more. And I am doing a good job of hydrating every time I do that because it just feels weird holding it there. Now, you'll notice that nothing here is really going to change because we still need to retrain the model. And that's totally fine. But it seems like maybe what we should do is add another class of maybe a no drink class. Well, wait a minute. Before we do that, so this is not the only water bottle that I use. I also use this water bottle. Oh, and look, isn't that interesting? It thinks this is a coffee mug. All right, so here's my coffee mug, which is patterned with a lot of colors that look like dots. And here is my other water bottle that also has flowers and dots. So it's interesting. I drank my water, but it's going to yell at me because it's going to think it's coffee. Let's see. I think I have another water bottle around here too. Yep, I do. This is normal. All the water bottles. Stay hydrated. Again, coffee mug. All right. So you can see how it works with our specific data, with the data sets that we've created. But that's not really useful unless you're using those same things all the time. So we want to make sure that we can, include all of these things that seem useful. Now, I think that, I also have a candle. I wonder what it thinks the candle is. I bet you it thinks it is a coffee mug. Yeah, because it's about the size of a coffee mug. Interesting. So when it's standing up, it thinks it's a water cup. And back is a coffee. I wonder. So here's my theory here. Yeah, absolutely. Bias is definitely bad. There's a book that I listened to. It was actually last winter because I remember shoveling snow while I listened to this book. I have to look it up. but it was a book on all of the bias in data sets and how that can impact not just the way that our models are coming out with results, but decisions that are made on higher levels. They talk about the problem with government decisions. I just realized that like there are now 2 of me on the screen. So maybe I shouldn't have been sharing this view too, but it's kind of funny because the 2 different faces are looking at each other. Anyway, sorry, I distracted myself. Oh, government decisions. So if you're looking at data and the data isn't correct, then people are making decisions based on that data. And then there are people that are left out even more because nobody is talking about them. Even the bias, this model is gaining that coffee mugs must have colors and flowers. Yeah, absolutely. That's such a great example. So let's see here. Let's take a look at, okay, so what were we doing here? We've got the water cup, and I know I said that I was going, okay, so I added more to the water cup. Let's take a look at the coffee mug samples. Whoops, that's not what I want to do. How do I make them bigger? Nope. Don't want to do that. I just want to see all of my samples again. Edit, maybe. No. Webcam. There we go. All right, so let's see here. So this is the water cup. Coffee mug. Interesting. So yeah, it could be the position. I feel like that position is similar, but there's also, you know, like this white bottom here, whereas with the water cup, we don't see the bottom at all. There's a different color there. And so what else? Okay, so now we're going to add another class here, which is going to be called No Drinks. I'm very good at labeling today. And now we are going to take more pictures, doing all the things. This is really normally how I look with my cheeks puffed out because I don't know why I do that, but I do. And I've also been like reading with one eye lately. I talked to somebody else and they say they do the same thing when they're trying to focus. So I felt like at least I'm not the only one that does the one-eyed reading for focus. All right, so now we have this data set and we're going to train the model again because we've added some data there. It needs to learn how to work with that data. And we're going to give it a second while it does that. And then we're going to maybe take a look at some other things or maybe train it to see other water bottles too and see how that impacts it. So yeah, so maybe if it recognizes that I have put my coffee mug to my mouth 10 times, then it's about time to take a sip of water. Or, you know, maybe I have something else. It doesn't have to just be water and coffee, right? You can look at all different sorts of things. Okay, look, now it knows that I have no drinks. Let's see. It's not really sure. It's mostly sure. Yeah, that's the one I thought. Something to the face. It's pretty good. Okay, so this is much more accurate. And so we learned that sometimes you have to look at, okay, what are we missing here? How should we be building this data set? I think I do want to add another water bottle class and see what happens when it identifies the mug. So we'll add, I'm going to add this one. Yeah, so definitely still thinks that's the coffee mug. Let's see. Definitely thinks it's a coffee mug. All right. Yeah, because this one is definitely, there's no pattern on there. Also, it's a straw cup, and that's different too. So if it's seeing the straw, we will do, what did I call this? Water cup. So again, we're going to do an excellent job of creating a new category here and calling it water bottle. So again, you should be more specific than that. This is where we're going now. All right, let's do this again. One more time for fun. $42. And then we have to turn the lights out. Try it again a little bit in the dark. All right, again, I hydrated during that whole time, and that I almost choked on my own water. That was too much water. Okay, so here we go. We're going to train this model one more time. We're going to do this again. I also have some Apollo hot sauce, so if you want to warn yourself not to drink the hot sauce, that would be a good thing to do in case you accidentally almost drink it. This is from Hot Ones, the YouTube show, and my friend Kirk got me the set for Christmas. It is very hot. I didn't make it to this one because I dumped a ton of the hot sauce before this one on a wing, and then I had to rinse my mouth out for a long period of time and soak my lips in milk. It was fun. It was my favorite Christmas gift. So shout out to Kirk for the best gift ever. All right, so let's see. This is good. And knows that we have no drinks. Now, let's see coffee mug. All right, it's pretty sure it's a coffee mug, but look at that last water bottle one tipping around. Ooh, look at that. It thinks that's a water bottle. Interesting. So now, see, when it sees the bottom, it's pretty accurate. When I start to turn, it's not really sure. And that's when we get the flowers. So it's really fighting itself here. I'm sorry for making you sad, model. You don't know what's happening. Okay, and even like when it's straight, when it's like slightly tipped, we're good there. Interesting. This is like, so when we were doing my son's science fair project last year, we did Lucky Charms. And so it was cereal or marshmallows. But there's different kinds of marshmallows, different color marshmallows. And for sure, it more consistently failed when the marshmallows were similar colors to the cereal. So color was a real indicator there. Okay. So now we have this. Oh, it definitely knows it is a water bottle. And it knows it's not a coffee mug. Let's see. And I suppose we could have just added that to the water cup category because we're not specifically looking for water bottle or water cup. We're just looking to see if we're hydrating with water. So it probably should have just been a water vessel category. Again, very good with the category names today. All right, let's see. What do you think here? Oh, hey, look at that. It knows it's a water bottle. That's good. Good job, model. Give it a treat. All right, put that down. All right, now what does it think the hot sauce is? So if you want to feel hydrated, you can also, oh, no, now it thinks I have no drinks. So I can't tip it. It's too hard to see. But here, it would allow me to try and drink this as water. We do not want to do that. So we've got a little bit more here. Let's take a look at this advanced tab just to go over some of the things that we see here. So this is called hyperparameters. And these are new vocab words kind of for us, new things that we're learning. And maybe, let's see if I can get my face off the screen here so you don't have to keep seeing that. That's a little bit better at least. So the nice thing about this too, the Teachable Machine, is if you hover over this, it gives you a description what each of these things are, but just to go over it here. So an epic is one full pass through the training data. And so that means at the end of one epoch, it has seen all of the training data at least once. So in this case, it has gone through it 50 times. So that's what epochs are. Batch size, so this is when it breaks it down into smaller sizes that are loaded into the memory, and it could probably handle all of these at the we don't have that much data in our data sets here, so it could probably handle what we have, but it's good practice, I think, to break it down into smaller batch sizes and a more reasonable size of things. And learning rate I know a little bit less about, but I do know it says even small differences can have huge effects on how your model learns. And so it determines how the model should adapt with each prediction. And so you might think that the higher learning rate is better, but that it's not always better. And it's worth noting. We're going to talk about that in a later stream. So if you want to take this model and use it, you can. Where is my export model? There's an export model button somewhere. Here we go. We can export this. And so, like I said, the cool thing about this is we can do TensorFlow.js. If you want to use TensorFlow or TensorFlow Lite, you have those options there too. And then it gives you this code snippet that you can use. Now, remember, this is not our data sets. You have to download those separately, and you can do that in GitHub. But for now, it's worth noting that if you go to the site on GitHub, there's a lot more information. I think that maybe I was frozen there for a second, but hopefully I am unfrozen. Okay, I think it's working again. Sorry about that. So we have, again, so you can go ahead and download everything that you worked on here. And something else worth noting too is that we talked about how built into Teachable Machine is the ability to use my camera, my webcam. So I didn't have to do any of that. And there's a package specifically for that called Teachable Machine Image. And I'll go ahead and drop that link. That is used to take care of the webcam and to censor things. Not censor, but like sense. You got it, right? All right, so we're going to talk just a little bit longer about some issues that we might face with machine learning and some different problems. So we talked about data sets. We looked at creating our own today and some of the things that can happen with that. I don't think that we need to share this screen anymore, so we're going to go back here so there's no risk of you having to see my face twice on the screen again. So small amounts of data can be problematic for your data set and for getting the right prediction, okay? And so the amount of data that you need for your problem is going to vary based on what you're looking for and what your problem is, but usually more data is better data. But you don't want to have poor data. So that would be our second problem. So our first issue would be small amounts of data. Our second issue would be poor data. This could be missing data. It could be mislabeled. It could be just flat out wrong data or bad data. It needs to be organized and it needs to be prepared. And so when we think about looking at other people's data sets, you can learn a lot from looking at them because you're able to see how experts in the field are arranging things, what they're looking at, how they're working with those things. And that will help you to learn how to create your own beyond resources. So I just want to say, I think it's worth looking at other people's data sets as well. Let's see what else. Oh, and sometimes your data needs to be scrubbed of outliers. We need to be prepared for our particular problem, and we need to get that data ready. The third problem that we might face is data bias. So we definitely talked about this earlier in the stream. You can have your data ready for what you think is ready, but our data is definitely influenced by our own biases. And I really wish that I knew the name of that book. Anyway, I'm not going to remember it. I think that it had like yellow people on the front. No. Anyway, it's not going to happen. I need to stop. But so, for example, our data set was looking at my particular water bottles. If somebody else wanted to use this, then their water bottle might look different. We're going to go back to the rash example because it's a good one. So a lot of the issues that we see with machine learning and image detection where we're working with people is looking at the data set might be all white people or mostly white people. So a rash on a white person's skin is going to look different on somebody who has darker skin. And so making sure that the data allows space for everybody who would be using this is really important. And that's why, people are often left out of medical data sets and are hugely impacted by that. So those kinds of things are really important. Bias doesn't have to be intentional, for sure. It can be unintentional. It can be things that you've internalized. But this is another reason why working with a lot of different people on a data set and getting feedback on that can be hugely important if you're going to be building something for people. So let's see, I think that was number 3. Small amounts of data, poor data, data bias. Overfitting would be the next one. And so sometimes our models are trained that it will only work with our training set. So if somebody else wanted to come in and use our model to see if they're drinking water or if they're drinking coffee, it's probably not going to work, right? If they don't look like me, if their background doesn't look like mine, that can definitely impact how this model works. They're going to be drinking out of something that looks different than what I am drinking out of. Their position might be different. Where the webcam is might be different. So all of these things, we might find that it's specifically looking just at our case. And that's not what we want. We shouldn't spend all of this time building data set and working with models if we're just looking for our particular thing to work. And in some cases, we'll find that when you run an overfitted data set, I guess, or our models, that it might be slower. It's going to be more likely to fail. And sometimes this is called high variance. So this is also why we have test and validation sets, because this helps us to understand what's going on and catch those problems before hopefully we do anything big or real with them. And then the last thing is underfitting. So when you're underfitting, your model isn't trained enough or structured in a way that prevents it from adapting to data. So it might fail in those situations. And this is often called high bias. So those are 5 of the big things that we see. We'll talk more about those, I think, in later streams, but they're definitely worth noting. We've got a couple more things. Before you jump into starting to collect your own data, you want to check if there are existing data sets that you can use instead, right? Especially if you're new to creating data sets and you want to do something meaningful with that data, use it with a particular model, then it's useful to look at what other people who have spent a lot of time doing these things. And so I'm going to drop a couple of links in the chat for that. Oh, wait a minute. This is all formatted. Let me fix this. Sorry. Okay, so these are 3 resources that are, and then it changed the way that I fixed it. Anyway, doesn't matter. These are 3 resources that you can use to look at data sets. They're pretty reliable. Let's see, I think I have them open here. So we have on the TensorFlow site, we have a bunch of data sets that there are different ways that you can look through things. And this is not TF Hub, where we're looking for models, but this is where on TensorFlow where we're looking for data sets specifically. So there are a lot of different ways that you can look through what's happening here and see what is going on with these things. Let's see. This one, it's a machine learning repository from Center for Machine Learning and Intelligent Systems. I'm starting to not be able to talk. Excellent. So here we've got more breakdowns of things that you can look for. Hey, Pittsburgh bridges. I live near Pittsburgh, so this is why I got excited. And now I am very interested in what I would do with a Pittsburgh bridge data set. But anyway, well, that'll be different for a different time. There was another one. Oh, Kaggle. Kaggle has lots of cool stuff. I've heard a lot of good things about Kaggle, and they also have, I think, like competitions and different notebooks and things that you can play with. Yeah, competitions, dataset code, discussions, courses. So there's a lot of different things that you can do on Kaggle that looks pretty sweet. I haven't worked with them yet, but it's on a list of new toys that I want to play with. And so lastly, if you want to do some searching on your own, we're going to go to datasetsearch.research.google.com, and we should definitely type in rashes to see, hey, somebody has an image set, Lyme's disease rashes. So Lyme's disease has a very distinct rash in some cases, but not all cases. But here we go, an image data set of various skin conditions and rashes. So see, I don't even need, this, it looks like, I don't even need to make my own rash data set. For sure I should check this out and see what their rashes look like. And then I can develop an app so I don't have to Google this anymore, and I can just point it at my kid's skin and it will identify their rash and let me know whether or not I need to take them to the doctor. So I know this has been like a shorter stream today, and I think that's okay because I don't think you all want to explore rashes anymore, but if you do, you can always hit me up on Twitter. It's Becca HW. That's what I am everywhere. And you can come back next week where we're going to be talking about, wait a minute, I got to remember what we're talking about. Training models. Okay, so that'll be pretty good. But I feel like this is a good way to jump back into the new year. We played a little, had a little fun, got a feel for what we can be doing with our tools. And that's it for today. So again, thank you so much. You can follow me on Twitter at BeccaHW. I will be back next Tuesday at 1 p.m. same time, and we will be working on training models. So thanks everyone for sticking around.